Okay, so this lecture is going to be over section 3.5. We're going to talk about relative velocity. So take a look at the picture here that has the plane, some wind, and a ground observer that's standing next to some trees. When an object P, for plane, moves relative to another object, reference frame B, which is going to be the wind, and B moves relative to a third object, A, the ground observer, we're going to denote the velocity of P relative to B by V with the vector notation P slash B. The velocity of P relative to A by the velocity vector on P slash A, and the velocity of B relative to A by the velocity vector of B slash A. So if you take a look at how these velocities are related, you'll see that the velocity of P slash A is the same as the velocity of P slash B plus the velocity of B slash A. And you can see these vector notations here. The velocity vector of P relative to B and the velocity vector of B relative to A is going to give you the velocity of P relative to A. So for another example, let's take a look at a situation where a woman is walking not down the aisle of a railroad car. So in other words, not back and forth like that, but from one side to the other. And she's walking with speed of 1 meter per second. We can describe the woman's position in two different reference frames, that of the railroad car and that of the ground. So we've got a cyclist over here who's stationary. The frame of reference of the stationary ground observer, A and T, is going to be the frame of reference of the moving train. So as this figure shows, the velocities are going to be related, as the velocity of the woman with respect to the cyclist is going to be the same as the velocity of the woman with respect to the train, and then the train with respect to the cyclist. So you can see here the velocity of the train with respect to the cyclist moving this way. You can see the velocity of the woman with respect to the cyclist this way, and you can see the velocity of the woman with respect to the train this way. So if you take the velocity of the train with respect to the cyclist as 3 meters per second, and then with the woman with respect to the train as 1 meters per second, then the woman with respect to the cyclist would be this side, which is the same as the hypotenuse of a triangle. So 3 squared plus 1 squared, and then take the square root, is 3.2 meters per second. The tangent of the angle that is made here, which happens to be 18 degrees, is going to be the velocity of the woman with respect to the train divided by the velocity of the train with respect to the cyclist. So it turns out to be 18 degrees. And the general rule is that if A and B are any 2 points in the frame of reference, then the velocity with A with respect to B is going to be equal to the exact opposite of the velocity of B with respect to A.